So we're going to concentrate on the angles in quadrant 1 at the beginning and get used to some of the vocabulary before we move on. So hopefully you remember SOHCAHTOA. It is the definition of all the trig functions, and hopefully you've taken a look at that or remember it from your grade 11 course. If not, please refer to the review material at the beginning of this unit. So the definitions are listed right here. The sine of theta is opposite over hypotenuse, so that's why the OH is there. And we're going to take another look at how we can define SOHCAHTOA in a more general way to make it more applicable to a wider range of problems. And to do that, we're going to take a look at the unit circle on the left. It is called the unit circle because it has a radius of 1. So if I swing that initial arm up and somewhere into the first quadrant here, it lands on this point right here, P, which has an x coordinate and a y coordinate. And that x coordinate is this long, approximately, and the y coordinate is this high. So in terms of the definitions of sine, cosine, and tangent now, if we take a look at this angle that we have swung in standard position, so here's our angle theta, and we look at the opposite over the hypotenuse, the opposite is the y value and the hypotenuse is the r value. So I can rewrite the SOHCAHTOA definition for sine as y over r. Similarly, I can do that for cosine and tan. So each of these acronyms that you used to use just in isolation without putting them on the XY quadrant, the XY quadrant plane, can now be translated into a different look. So sine is y over r, cosine is x over r, and tan is y over x. And we're going to be using these for the most part for the rest of the lessons. The other thing you might recognize here, this is Pythagoras, and it's a squared plus b squared equals c squared in disguise, because notice the c, which is the hypotenuse, in our case is the radius. So from now on, we'll see x, y's, and r's instead of o's, h's, and a's. So if we plot the point 2, 6 on the coordinate plane, so 2, 6 would be something like that, where this distance is 2 and this distance is 6. And here's my angle in standard position. So it's on the terminal arm, and I want the 3 trig ratios. So if I want the three trig ratios, I need to calculate the radius or the hypotenuse. So r squared equals x squared plus y squared. So r squared equals 2 squared plus 6 squared. So r squared equals 40. So r is the square root of 40. Now it's a really good habit to simplify radicals, and square root of 40 is 4 times 10. And the reason I write it this way is because the 4 is a perfect square, so I can pull that out and it becomes 2 root 10. So now if I use my definitions for the trig functions, the sine of theta is y over r, y is 6, and the r is 2 root 10. Remember, this is 2 root 10 here. So I can simplify that fraction as well, because 2 divides evenly into the 6, and I get 3 over root 10. Now, second trig function, the cosine of theta is x over r, which is 2 over 2 root 10. Cancel these, and I get 1 over root 10. And finally, the last one, which is the tan of theta, is y over x, and y over x is 6 over 2, which equals 3. So my 3 trig ratios. So let's plot 4, 7. And 4, 7 is in the first quadrant. We're going to go over 4 and up 7. And there's point P, and we're going to draw to the origin, so that indicates the angle theta. Now if we're going to find the distance of P to the origin, we need to use Pythagoras. So r squared equals x squared plus y squared. So it's just getting practice with using these new symbols for Pythagoras. 4 squared plus 7 squared, which is 16 plus 49, which equals 65. So we know we take the square root of both sides and we get the square root of 65. Now normally we go plus or minus 65, but we understand that the radius is always positive. So the radius is going to be the positive square root of 65. So now to answer the question about the primary trig ratios, using our definitions of y over r, the sign is 7 over root 65. The cosine ratio is x over r, which is 4 over root 65. And lastly, the tan ratio is y over x, which is 7 over 4. So let's take a look at another flavor of this type of question. We've got information about the tangent ratio here. And we are told that theta is in quadrant 1. So we're going to draw an angle in quadrant 1, and this has to be theta here, going counterclockwise. Now we're going to use the tan ratio, which is y over x, to help us figure out the rest of the triangle. So the y value has got to be 5. So this distance here is 5, and the x value is the square root of 7. So that gives us enough information to figure out what the radius is going to be. So radius is x squared plus y squared. Radius is the square root of 7 squared plus 5 squared. Now the square root of 7 times the square root of 7 is the square root of 49, which is 7. So r squared equals 7 plus 25. So r squared equals 32. And the square root is plus or minus square root of 32. Now we're going to ignore the negative because we know that radius can't be negative. And in addition to that, I'm going to do a little bit of simplification. So square root of 32 is 16 times 2. 16 is a perfect square, so I'm going to pull that out. Square root of 16 is 4 root 2. So my radius is 4 root 2. And then I go back to the question. I said find the cosine ratio. So the cosine ratio is x over r. The x value was root 7, and the radius was 4 root 2. So let's take another twist on this material. We're going to draw an angle in standard position of 25 degrees. So 25 degrees in standard position. I'm just approximating there, maybe exaggerating a little bit so we can see what we're doing. So this is 25 degrees. Notice I went counterclockwise. And the radius of the terminal arm is 8 units long. And the question is find the coordinates of point P on the terminal arm. So here's point P, and we want to know what the x coordinate and the y coordinate is. So in other words, how far over, which would be the x coordinate, and how far up, which would be the y coordinate. So we're going to use trigonometry to do that. And if we are using the SOHCAHTOA or our definitions that we just learned related to y, x, and r, we know that the sine ratio of 25 degrees is y over r. So the sine of 25 degrees is y value, which we don't know, over the radius, which was 8. So multiply both sides by 8. Cancel on the right, and you have y equals 8 sine 25 degrees. And if you use your calculator, you should get an answer of 3.38 units. Now on the to get the x, I'm going to use the cosine ratio. So the cosine of 25 degrees is x over r. So the cosine of x is x. So cosine of 25 is x over the radius, which is 8. And the multiply both sides by 8 again. And so I get x equals 8 cos 25 degrees. And entering that into your calculator, you should get an answer of x equals 7.25. And it's important to just do a little double check to make sure that you haven't made any really big errors, because the radius should definitely be bigger than both of these sides. So that's one way to check at least some of your calculation errors.